Welcome to ERC TipsKnowLogy. In this video, we will be talking about 8051C programming, and the problem is about toggling or blinking one LED using different techniques. The first technique that we will be talking about is using some sort of a delay with the use of for loop commands. The second technique is by using a user-defined delay like MS delay. The third one will be talking about the timer delay, and then the last one will be using an interrupt to generate the delay. Let's start with the first one. The first one is using some delay, and in this example I will be showing you the circuit, the algorithm, the flowchart, and the C program. So the problem is that we have a green, yellow, red, and red LEDs connected at port number 1. Port 1 has 8 pins, but we will just be using P1.0, P1.1, P1.2, and P1.3 port pins respectively. So green will be on P1.0, yellow on P1.1, red on P1.2, and the other red on P1.3. Now we will make an 8051C program that will continuously toggle only the yellow LED with the use of some sort of a delay. And we will assume that all LEDs will be connected as active low. So these are the LEDs. As you can see, the LEDs has the long leg, which is called the anode, and the shorter leg will be called as cathode. So we will be connecting, usually we connect the cathode on the negative side and the anode on the positive side to make it forward bias and to make it work. Now we have here the sample of a variant of the 8051 microcontroller. This is the 8089C51. Now the pin diagram of 8051 shows you that it has 40 pins, and the first port is called the port 0, and each port has 8 pins. So port 0 is on pin number 39 down to pin number 32. And pin number 39 has the first port of port 0, which is used as an input or output port, and at the same time that can also be used as an address or data. So we have 8 pins that represents the ports 0, and each of them can be used in 4 ways: as an input port, output, address, or data. Now the second port is the port 1, and just the same, we have 8 pins, and these pins are on pin number 1 up to pin number 8. So the first one is called P1.0, and the last is up to P1.7. Now we will be using P1.0, P1.1, P1.2, and P1.3 for our diodes or our LEDs: green for P1.0, yellow 1.1, red 1.2, and another red 1.3. So this is where we will be connecting our LEDs. Now the third port is called port 2, and the first pin of port 2 is on pin number 21, which is called P2.0. So it can be used as an input port or as an output port also, and at the same time we can also use it as an address. So the port 2 will support the 16 bits address that we need, because port 0 can only take from address 0 up to address 7. So that's equivalent to 8 possible addresses. So if we need 16 bits, then we need to use another 8, and that will be supported by port 2. Now port 3 also has 8 bits or pins, starting from number 10 up to 17. So just the same, we call it P3.0, 3.1 up to 3.7. And each port is an input or output port also, plus it has a specific function different with the others. For example, for P3.0, it can be used for receive, RXD, and then 3.1 is TXD or transmit. Interrupt 0 and interrupt 1 on P3.2, 3.3. Timer 0, timer 1 on 3.4 and 3.5. write signal will be on 3.6 and the read signal will be on 3.7. And of course, we have other parts like the reset on pin number 9, Xtal1 on 19, Xtal2 on 18. We have, of course, the VCC on pin 40, the ground on pin 20, and we have PSEN on 29, ALE on 30, and EA on 31. So let's see the algorithm. First, the circuit before the algorithm. So this is the circuit, and as given in the question, port number 1.0 up to 1.3 are connected to green, yellow, red, and red LEDs. So the cathode of the LED is connected to the resistor, which is connected to P1.0 for the green, and the same way with the other LEDs. Now the reset pin is connected to resistor R1, capacitor C3, which is 10 microfarad, and the resistor is 8.2 kilo ohms, and our reset button here. Now the other end of the resistor is connected to the ground, and we have the capacitor. The other end is connected to the power supply, and also the other end of the push button switch is connected to the power supply. Now the power supply is also connected to EA. So this is the proper connection of our 8051 microcontroller circuit. Next, we have the algorithm, and of course we have number 1, start. Then we have to include the header file reg51.h, and then step number 3, we have to declare the variable for the delay, and then for steps number 4, 5, 6, and 7, we have declared the port variables for P1.0 up to P1.3, which represent the green, yellow, red, and another red LED. Then on line number 8, or our step number 8, we have to declare the main function, and we will have to start on step 9. And inside the main function, we have to make our ports to be as output ports. That's why we have P10 up to P13 as output port pins, because it's an LED, a light, so we call it as an output device. Then on line number 14, we will be repeating step number 15 up to 21, and this contains turning off the 3 LEDs, green, red, and red as off, and we will be toggling or blinking the yellow LED. Then we will put some delay, and that's the end of our while true loop. So this will be repeated continuously with that delay. And of course, we have the end of the main function. Now let's look at the flowchart. So for the flowchart, we have the start, and then inside the preparation box, which is a hexagon, we write here all the variables that we will be using. So X, P10, P11, P12, and P13. And we simply put 0 for X, and we denote, or we say that P10 is P1.0, P11 is 1.1, 12 is 1.2, and 13 is 1.3. So these are just to represent the declaration of the variables. Now this part will tell the system that we will be using the ports as output ports. That's why we put 0. Then we have the decision box to say while true, so that it will be repeating continuously. The first one is to turn off the green LED. The second one is to toggle the yellow LED. The third is to turn off the red, and then the other red will be turned off. You will notice that we use the number 1 instead of the normal 0, because this is an active low LED. So for active low LED, we have to put 1 to turn it off, and to turn it on, we have to put 0. But if it is active high, we put 1 to turn it on. And then we will do the delay, so we will start the X to be 0 until it reaches 10,000. But if it is from 0 to 9,999 or less than 10,000, it will continuously increase its number. So it will just be counting from 0 to 9999. That will be equal to 10,000. Now when it reaches 10,000, of course, 10,000 is not less than 10,000. So we will go on this way. We will go to the false. That 10,000 less than 10,000, that will be false. So we will go back to while true. And when we go back, we turn off all the 3 LEDs except the So the yellow will be toggling between on and off. So before it was off, so 1 will become 0. So now it will be on. And that will be repeated continuously unless we stop the program or we stop the execution of the project. Now, the program, let's look at the program now. You will notice that there are some remarks or comments on the right side, which is not really necessary unless it is needed. So in the beginning, I just put here toggle yellow LED so that we at least know what it is. And then the inclusion of the header file. We declared the variable here for X. And then all the 4 ports, P10 up to P13, were declared. This is the proper way to declare the port variables. So we use the caret symbol instead of the period. So P10 equals P1 caret 0 and up to P13. And then we have the main function starting from line number 9 up to line number 22. And then on P10 up to P13, we made it 0 to make it as output ports. And then while true is while 1 in C language. And that will be from 15 to 21. And then we have here P10 equals 1. And also with P12 and P13. So the green, red, and red will become off. Again, remember, this is active low. And we have here, we have used 10,000. This is approximately 1 second, although it's not exactly 1 second because we can only have an exact value of 1 second if we are in the timer delay. But this is just a normal for loop delay. That's why you see here with some delay. So it means it's not necessary to use 10,000. You can use any other number as long as the blinking of the LED can still be observed while you are running the program or you're executing the program. So there you go. This is the first program for today. This is the program that will blink the yellow LED with some delay. Let's see the execution of the project or the program. So in this simulation, you will see that the yellow LED on P11 is now blinking almost every 1 second, but this is not necessary. Again, I just used 10,000, but you may use any other values. Now, if you will observe the LED is blinking every second or almost every second, and the other 3 LEDs are not working. We don't really need to put the 3 LEDs, but just for example that we will be using the same circuit later on, like for example for traffic lights, that's why we have the other 3 LEDs there, and to show how to turn off the other LEDs. Now let's move on with the next example, which is toggling an LED using a user-defined delay function. And in the book by Mazidi, we have an example there that uses MS delay. So let's go ahead with the example. So we have again the same green, yellow, red, and red LEDs connected at P1.0, P1.1, P1.2, and P1.3 port pins respectively. So we will still make an 8051C program that will continuously toggle only the yellow LED, but this time with 250 millisecond delay. So if you will approximate it, assuming that 10,000 is 1 second, then 5,000 will be half a second or 500 milliseconds. And 250 milliseconds is like 1/4 of 10,000, so that would be like 2,500. So we have to make a for loop delay that will be counting from 0 to 2,499. And we will do that using a user-defined function, MS delay. When you say user-defined, it's not part of the C language command function, but you will be making your own name or your own function name. So let's see the algorithm. So the circuit will also be the same with the previous circuit. But of course, the algorithm will be different in some way or some ways. So the first one starts still the same. We start our algorithm with start. Again, algorithm is words or words representation of the program. So you don't it's not necessary to follow any particular way to write your algorithm as long as the logic of the program is there. I mean, the program, how will it run, what will it do. Even if you write it in any language, English or not, then it's okay. So we write it here like start, then we include the header file, and we declared all the 4 ports. But you will notice that we did not declare any X variable, because in this algorithm or program, we will not be needing it. Then we have we have to declare the MS delay function with iTime argument. So if you're familiar with a function, when you say void, it means that you will not be sending or receiving any values whenever you call a function. And if you want the function to receive something, or if you want to send a value to a function upon calling it, then we have to put a variable that would accept the value that you will send to it. And that's what we call as argument. Now, the step number 8, we will start the delay function, MS delay, and inside this, you will notice that we declared 2 variables, I and j, and the first one, letter I or variable I, will be counting from 0 up to the number that you passed to it. Like if you passed or sent 250 to the function upon calling, then it would be like from 0 to 249, and that would be like 250 because you started with 0. And that's why I represented it here as the I time that will receive the value that you pass or you sent. And we need to subtract 1 to it to represent it like 0 to 249 to make it 250. And then we will just repeat step 11, which is doing nothing 10 times. So it will be like 250 done 10 times. That will be 2,500. And therefore, we will be getting 250 milliseconds or 1/4 seconds or 1/4 of a second. And that's the end of the MS delay function. So this is the new things done compared with the use of a simple for loop delay in the previous example. Then on line number 13 up to line number 27, this is our main function. And we will be doing step number 14 up to 27. And we start with 15 up to 18. This is where we put the ports as output ports. And then on line or step number 19, we have here while true. We will do steps 20 up to step 26. And that will be to turn off the green LED, to toggle the yellow LED, turn off the red LED, turn off the other red LED. Now, in the previous example, we'll use a simple for loop, which is counting from 0 to less than 10,000. And this time, we will call the MS delay function. So from step number 25, it will go back to step 7, which is where you have your MS delay function. Again, the task that the MS delay will do is to just do nothing 10 times, but the 10 times will be repeated depending on the number that you sent. So we sent 250 together with calling the said function or subroutine. So it will be repeating 250 times, doing nothing 10 times. That will be, as I have said, 250 done 10 times. That's 2,500. Thereby, that count would represent the 250 milliseconds delay. Now, in the book by Mazidi, we will see that they use the number 1275 in the repetition here instead of repeating 10 times. But when I tried it with the simulator, it did not do the 250 milliseconds delay. So I changed it to 10 to make it like 2,500. Now let's see the flow chart. So the flow chart, like what I've said, there's no more need for the X variable. So we don't have any X variable over here, only the P10, 11, 12, and 13. And then we declared after declaration of the ports, we say that it is an output port for each. And then while true, we did the same. We make the green, the red, and the red LED, the 2 reds to be off, while the yellow will be toggled So take note of the tilde or the tilde symbol. This is the one responsible for taking the opposite value of 0. It will become 1, 1 will become 0, thereby making the off on, and the off and the on will become off whenever you repeat this step. And instead of having a for loop here, we have a new symbol. This is called the subroutine symbol, and you will see the two lines on the left and the right for the rectangle, and then the name ms delay. Actually, we can write here ms delay 250 just to point out that we are also passing 250 upon calling the ms delay function. That's why we have a separate ms delay flowchart, and inside, just like what have been mentioned in the algorithm, we declared the two variables I and j, and there will be two for loop. The first for loop will be for I, which will be starting from 0, and it will be repeating the true part while it's less than I time. Now, if I time is 250, then it will be 0 less than 250. That will be true up to the point of 249, it's less than 250. So it means this part here will be repeated 250 times. And you will see here letter J, which is J less than 10, and then J plus 1. So what will happen here is that the J will be counting from 0 to less than 9, 0 to 9, that will be 10 times. And 250 times mula 250 times 10, that will be 2,500. Just like what I have pointed out. So after counting 10, it will become 10. Is 10 less than 10? It will be false. And then the I will be incremented. So I started from 0. Now it will become 1 after counting 10. And then it will repeat 10. And then it will become 2. After counting 10, it will become 3, and so on until this reaches 250. That's how the 2 for loop will be happening, or the 2 repetition will be happening. So take note of the symbol for the subroutine, this one, two lines on the left and on the right. Now let's move on with the program. So in the program, you will see that in the beginning, we did not declare the X variable, but we have the inclusion of the header file, and then we have the ports here declared. And on line number 7 up to 12, this is the part where we need to declare the delay function, and it's user defined, so we can use any other name, not only ms delay. You can even use your name if you want, but we put here ms delay, maybe to represent milliseconds, but we should have written small letter m and s. And inside we have the variable I time, which can just be the letter I, but we also used I here, so you can use other names, not just I time. You will see that in the example in Mazidi's book or textbook, there's I time also there. And then we have the same IJ, and then the 2 for loop here, where the first one is I less than I time, so we did not write any number. So the I time is actually the 250 here. When you call the function from 25, it will go to 7. And at the same time, 250 will be received by I time. That's why here, it's like I less than 250. So from 0 to 249, it will be true to repeat 0 to 9, which is 10 times. That's how the ms delay works. Basically, it's still a for loop, but we just put the for loops inside a user-defined function. If you want, you can cancel the user-defined function and simply put the 2 for loop here on this part instead of the ms delay 250, and no need for the ms delay user-defined function. So it just made it look nice, but we can shorten this program by just putting these 2 lines here, and the declaration will be here at the top. Anyway, this is the program for the second technique, which is using the ms delay function or a user-defined function. Now let's move on to the third example, which is, by the way, I forgot, this is the simulation. More or less, this is like 250 milliseconds on and 250 milliseconds off, or 1/4 of a second it will be on, and 1/4 of a second it will be off. There you go. So let's move to the third one, which is using a timer delay function. So we have the same question, but actually this is not, we will be blinking the LED not by 250 milliseconds, but by 1 second. So there's an error here on this part, this one. Okay, so this is actually 1 second. So we will make an 8051 program that will continuously toggle the yellow LED with 1 second delay, and we will be using timer 1 in mode 1 to generate the delay. Of course, it is expected that you already have a knowledge about timers. So if not, you can watch our previous videos about timer. Just watch it in and look for it in our videos. So let's move on. Anyway, it's the same problem except for the use of timer in mode 1. So what's the difference? In the algorithm, you will see the start is the same, include the header file. Like in technique number 1, where we used some delay, we again declared the variable x because we need it for repeating the timer delay later on. And then from step number 4 up to step number 7, that will be the same declaration for the port variables for the LEDs. And then on step number 8 up to number 17, this is the new thing. This is the main difference between the first and second and this example. So here we set the timer mode to timer 1, mode 1. And remember, there are two timers, timer 0 and timer 1. And to do that, we have to make the value of T mode to be specific. It must become 10 hex. So the hexadecimal number 1 is representing 00001, and the hexa number 0 is representing 0000 in binary. So watch our videos about timers and you will understand what I mean by this. But to make it timer 1 mode 1, we need to put 10 to assign 10 to the T mode. But because this is just an algorithm, we don't really need to specifically say it. But like as in assign 10 hexa to T mode, if you want, you can do that too. Then we assign this one is specific 4B hexadecimal number and FD to our timer registers TH1 and TL1, because if you watch our videos about this, we have to calculate for the timer delay, and 4B FD is the timer register values for TH and TL that would give us 50 milliseconds of delay. And then we run the timer 1, and while the flag of timer 1 is still 0, we will do nothing. And then we stop the timer 1 and we set the flag of timer 1 to 0. So more or less, this is the usual contents of the timer delay function. Now in line number 18 up to number 33, this is our main function. And we have here the start up to the end. And inside the start, line number 20 to 23, we set the ports as output ports. And then on line number 24, we have the while true step, or step number 25 up to 32. So you will see here the start of the while true up to the end of the while true. And then we turn off the green, we turn off the red, we turn off the other red, and we toggle the yellow LED. So that's it. This is the algorithm for blinking the yellow LED using timers, or timer in mode 1, timer 1 in mode 1 to generate the delay. Now for the flowchart, we have here the initialization box or the preparation box, the same with the other example in the first part. So X, the P1, P10 up to P13 were declared. P10 to P13 were made to be output ports, and then we have while true off for the green, red, and red, and the toggling of the yellow LED, and this will be the difference. We used here a T1 M1 delay subroutine. So for T1 M1 delay subroutine, we have to put T1 M1 delay with the number 250. Oh, sorry, we don't need to write 250 here. We don't have to. So we have only T1 M1 delay, and it will call the T1 M1 delay, which contains setting the T mode to 10 hex, which will be making it as timer 1 in mode 1, and also timer 0 in mode 0, but particularly we will be using timer 1 mode 1, and then the 4BFD hexadecimal values for TH1, TL1. Again, you may also start with TL1 equals to FD, and then TH1 equals to 4B, whichever you prefer to start with. And then we run the timer, TR1 equals 1. And while the timer flag of timer 1 is still equal to 0, then it will just go back and do nothing. The value of the timer flag depends on the automatic assignment done by the microcontroller. While it is not yet done, it's really 0. And if it is done, then with the delay, then it will automatically put 1 on the timer flag. And then this will become false because 1 is not equal to 0. And then we stop the timer and we clear the flag. Because the microcontroller makes the flag timer equals to 1 when it is done with its timer. And that's why we need to make it 0 again. So basically, these are the commands or the things that we do inside the timer delays. Now for the program, the comments, again, as I have said, is not really necessary unless needed. But I just put it all here. And you will notice that I use some indentation in the preparation of the comments so that it will be more readable for us. So it's okay to do this when you write the algorithm, although, of course, it should be aligned like number 9, 10, up to the 33rd step must be aligned. So let's just focus ourselves with the difference. So again, there's a declaration of the X variable again here. And from line number 8 up to 17, this is the part where we declared and we write what will the timer delay do. And the name of the timer depends on you. It's also user defined, but it would be better if we write T1 so that we know we are trying to solve a problem which is about T1 or timer 1, mode 1. That's why we put T1 M1, although it does not really matter. But for understanding purposes, we make it like this. Even the word delay, we can just make it D. Actually, we can just make it letter T to make it very short, T, and then the name of the function will just be T. So this is the setting of T mode to be timer 1 mode 1. The timer registers assignments for 4BFD to make it 50 milliseconds. And then you will think like we need 1 second, but why it's 50 milliseconds only? I'll explain that later. And then we have here the running of the timer, flag will be checked, and then we will clear the flag, we will stop the timer also. So the part where the 50 milliseconds will become 2500 will be here. Or the 50 milliseconds will become 1 second, I mean. How will it be 1 second? It's supposed to become around 1000 milliseconds so that it will be 1 second. So we need to multiply 50 by 20 so that it will be 1000. That's why we have here x less than 20 so that the 50 milliseconds delay of the timer delay will become 1000 milliseconds. So when you call the timer delay, it will be called 20 times, which will give us 50 milliseconds 20 times. That will be 1000 milliseconds, and that will be 1 second. So if we want 2 seconds, what number will we put to 20? We will simply make it 40. Okay, so if I want 1.5 seconds, we will just make it 30. I hope that's clear. In other words, it's like we can use the 4BFD to represent 50 milliseconds, but we can change the value of 20 to any number to be aligned or to answer the question for 1 second, 2 seconds, and so on. So there you go. That's the third way to generate the delay and to make the LED blink. Let's see the output. That's it. So the yellow LED will be turning on for 1 second, turning off for 1 second, and so on continuously. Now, the last technique that we will show now is the generation of the delay by using the interrupt. Of course, you need to have a knowledge about interrupt before going on with this example. If not, you may just visit our video about interrupts to have a background, what is an interrupt and how it works. So I'm assuming that you already have this background. So again, we will do the same problem, 1 second delay, but this time we will notice the word interrupt in the question, that the delay 1 second will be provided by the use of an interrupt and not a timer. So the algorithm, let's see what's the difference of this algorithm compared with the other 3 algorithms. So we declared X also. So it's like the use of the sum delay, step number of technique number 1 and number 1 we use X, and number 3, which is for the timer, we also use X. Now in this 4th example, we use X again. By the way, you can use any other letter, not just X. And this one is for the repeating the, actually not, yeah, the timer delay, but we mean interrupt, inside the interrupt, the timer inside the interrupt. Now the declaration of the ports again here, and then we will have here step number 8, which will declare the timer 1 mode 1 interrupt service routine, and that will be from number 9, start of T1 M1, up to number 22. I should have put the 22 here on the left, but this part is the important part for the interrupt. So inside the interrupt, T1 M1 ISR means interrupt service routine. So what is an interrupt? It is when a device is requesting the service of the microcontroller, then the microcontroller will stop whatever it is doing, and then it will do the service for the interrupt. And to do that, it will the interrupt must be provided with a task, and this task is inside a subroutine or a function. That's why we call it as interrupt service routine. To make it easy, we call this routine whenever there's an interrupt. Okay, so this is the interrupt service routine. Actually, I think this is wrong. This is not turn off green LED, or all LEDs are all off. So this part is not turn green LED off. It must be like toggle the yellow LED. So we're supposed to use here yellow, and that yellow LED must be toggled, not the green. So maybe I copy pasted the algorithm. That's why it's like that. And here we are supposed to turn off the red LED, and here we have to turn off the red LED also. So I'm sorry for that one. Then we have the start of the repeating 20 times, like what we did in the timer. And here you will notice that we have again the 4BFD to make it 50 milliseconds. And just like the timer, while the flag of timer 1 equals 0, do nothing. And then we make the flag timer to be cleared. But you will notice that there's no TR here. We did not use TR1 equals 1 or TR1 equals 0. So if you will go back to our example for the timer, for timers, we have here TR1 equals 1 and TR1 equals 0. But for the interrupt, we don't need to do that, because in our main function, we have here a part where we run the timer 1 here. Okay? And when you do that, and the timer 1 is represented as an interrupt here, then the interrupt will run. We did not even mention the name timer 1 mode 1 interrupt service routine. We did not mention. All we need to do is to just run the timer 1, and you will see that in the program later on. But this will be running, and it will give the delay, plus it will also make the LED blink, the yellow LED to blink every 1 second. Because of the interrupt service routine actually contains the blinking of the yellow LED and the delay, which is similar to the timer, except for the fact that there's no TR inside it. And then on in the main function, we will see that it's similar to the previous examples where we declared the output ports for P10 to 13, and we set the timer 1 mode 1 in the T mode, and we run the timer 1. But you will see here that we have an extra step here to enable the timer 1 interrupt bit. and we have to enable all the interrupts. So that's the difference. This one, number 30, number 31, also needed whenever you make a timer interrupt program, you may pattern it from here. And of course, we have while true, do nothing. So it's like let's just assume that the microcontroller is doing nothing. And when there's an interrupt, then the interrupt service routine will run. But we represented the interrupt by simply running the timer 1 here. So it will always call this interrupt service routine. Now for the flowchart, the difference, let's just talk about the difference. So same with the previous one here, the same here. But here it's different because we have here the timer mode set as timer 1 mode 1, and of course timer 0 mode 0 also. But we will just use timer 1 mode 1. And then the timer was run in TR1 equals 1. And then ET equals 1 and EA equals 1. So that's the port where we enable timer 1 and we enable all the interrupts inside the timer registers. Or the timer 1 interrupt will be running. But EA will be to make all the available bits inside the registers usable or enabled. And that would be in the timer interrupt explanation videos. If you want, you can visit that video. Then we have while true again. And it will simply do nothing. And of course, it will never go to false, although I put false there. Now, the timer interrupt, although it was not mentioned, by simply running the timer 1, it will automatically run the timer interrupt. And it will do the blinking of the yellow LED and the turning off of the 3 LEDs. And then, this is the one where it's counting 20 times to do the 50 milliseconds delay. That's it. So these are all inside the timer 1 mode 1 interrupt delay, which is not just giving the delay, but we also put the necessary blinking of LED here. Now for the program, let's just look at the difference compared with the other examples. So we have the same here, except this part, which is the heart of the program about the interrupt. But take note, although I use timer 1, we need to put interrupt 3. This is very important. And then if you're using timer 0, you need to put interrupt 1. Do not put timer 1, interrupt 1, and timer 0, interrupt 0. It's necessary to put the number 3 here for a timer 1 and number 1, interrupt 1 for timer 0. Although I did not give here timer 0. What I'm saying is that if it is timer 0, this must not be 0. It must be 1. Unusual, right? But you have to remember that. Timer 1, interrupt 3. Timer 0, interrupt 1. What's the error usually? Timer 1, interrupt 1. Timer 0, interrupt 0. That's wrong. You have to put 3 for timer 1 and 0 for timer 3 for timer 1 and 1 for timer 0. See? Now, the next part is the controlling of the LEDs, blinking of the yellow LED, repeating the 50 milliseconds 20 times. Again, there's no TR1 here because we already have TR1 over here in the main. And this is really like this while 1 because it's not really doing anything while 1. So this is just for example, but to call the timer, it's because of this. TR1 equals 1 for demonstration purposes. So it will go to T1 M1 interrupt service routine. And let's see the output simulation. There you go. So you can see that the yellow LED is blinking every 1 second. And here is the interrupt example for giving that delay. So thank you so much for watching this video about 8051C programming, where we toggled the LEDs in different way, not just with some delay, but with using a user-defined function. And we use timers and we use the interrupt delay. Thank you so much. I hope you will support this channel by subscribing so that we can reach 1,000 subscribers. Right now, I only have around 340 or 339 subscribers. So I hope that you will help me by subscribing and sharing these videos so that we can help others who are beginners in microcontroller programming. And please watch some of our other videos about Arduino, about basic electronics, and later on about computer programming and some robotics examples later on. Thank you so much and have a nice day.